Hey guys, Marcus Lechner here, and I 3D printed these magnetic socket holders to upgrade and organize my tool collection. These are just a few of the many upgrades that I designed to make my Packout toolbox functional and organized. Like many of you, my first toolkit was a multi-set with a blow-molded tool case. These tool cases aren't very functional. Some of the sockets aren't held in so they fall out all the time, and the sockets that don't fall out seem to be stuck. You even need to get a pry bar sometimes to get them out, or smack them to put them back into place. There are magnetic socket holders out there, but they can't guarantee that different size sockets will fit in there nicely. They might also leave out sizes that I have in my set, like this 24mm impact or these 4.5 and 5.5mm sockets. Therefore, I decided to make my own custom magnetic socket organizer. That way, each slot is custom to each socket so that they can be held in perfectly. I can also ensure that there will be a socket spot for any in-between sizes so that no socket sizes are skipped. For this project, I pulled the trigger on a 3-drawer Milwaukee toolbox. I had my eye on this for a while, and it's going to enhance the toolset's organization. The first step is to lay out all my sockets and figure out how I want to organize them. I want every socket to fit just perfectly. It can't be too loose, otherwise the sockets can get knocked over, and it can't be too tight, otherwise it will be hard to put the sockets back in its place. Another benefit to custom making these organizers is that I have a lot more options when it comes to laying out my toolbox. Before I start designing, I need to mock up how I want these sockets organized and grouped together. Next, I opened up my solid modeler and began designing. I used equations in the sketch so I could easily duplicate and adjust the design for each socket set group. Adding chamfers and fillets always makes your design more aesthetically pleasing. After I was done designing, I brought the STL file into a slicer and generated the G-code and sent it off to my 3D printer. To hold these sockets in their place, I got these rare earth magnets from Amazon. Now that all the parts are printed, I can begin assembly. I'm happy with how these magnetic socket organizers came out because they assembled easily, the sockets are held in perfectly, and they look great. The magnets are so strong that I can stick these sets wherever I'm working, under my cart or overhead. In total, I made 8 socket organizers, an impact half-inch and 3/8, both metric and standard for each one of those, and organizers for my deep and shallow sockets, again metric and standard for each one of those. I love these magnetic socket holders so much that I got to thinking what else I can make with these magnets. I immediately thought of my 30-piece gear wrench set holder that has no organization. So I got to designing, and after a few iterations, I was left with 2 magnetic holders for my wrenches, one for metric and one for standard. I slide in the magnets and they're ready to hold my wrenches. Now it's time to toss all of these magnetic organizers into my Milwaukee Packout toolbox. The top drawer will have my metric set, both 3/8 and half-inch drive sockets, along with my metric wrenches. The half-inch socket set is smaller, which works out great when fitting them in because of the angle of the wrench set. The middle drawer will have the standard set, 3/8 and half-inch drive sockets, along with the standard wrenches. The bottom drawer is where my ratchets, extensions, and quarter-inch drive sockets will be. I have a separate small Packout box that I'll carry my impact sockets in. Both my stubby and speed ratchet are 3/8, so I only need my 3/8 drive impact sockets here. This socket set is smaller, so I made the holder shorter so that they fit in here nicely. The top organizers can hold miscellaneous tall sockets as well as extensions and swivels. I was thinking about some other improvements I could make to my toolbox, and these Bosch tools came to mind. I decided to 3D print an adapter to accept Milwaukee batteries to make these old tools functional again. I got these tools for cheap because the batteries are dead, and due to the cost of getting replacement batteries, you'd be better off buying a new tool. They don't make them like they used to, and it would be a real shame to see these tools go to waste, so I'm determined to bring them back to life. I was thinking about converting them to corded tools to use an AC to DC power supply, but I quickly calculated that you need a huge power supply to deliver the amps needed. This was verified when I maxed out my 10 amp benchtop power supply to run my Sawzall. It was so weak I could even stop it with my finger. Right away, I knew this idea wouldn't work. Not to mention, corded tools are a pain to deal with, and the power supplies would probably cost more than the tool. Then I thought about my cordless Milwaukee tools and how they're also 18 volts. I realized that the best solution is to make an adapter so the Bosch tools could run off Milwaukee batteries. The Milwaukee batteries are easy to get, unlike the out-of-production Bosch batteries. Additionally, I prefer the benefits of lithium chemistry batteries. The first step is to disassemble the Bosch batteries. I'm going to use the top of the Bosch battery and print an adapter for the bottom half. To get the profile of the Bosch battery, I scanned the bottom of it and traced it in my solid modeler so that the part lines up exactly. This tip helped me reduce the iterations and allowed me to quickly and easily copy the curvature of the profile of the Bosch battery. I then merged this with a CAD file of a Milwaukee battery circuit. cleaned up the part by adding fillets and chamfers and brought the STL into my slicer so I could configure the G-code and send it off to my 3D printer. Everything clicks together nicely and the parts join completely flush. Now that I'm satisfied with the fitment, I printed 3 adapters, all in black. Next, I need to add some contacts and wires to make this adapter functional. I soldered leads onto the spade connectors and press fitted them into a slot. Now that I've finished making an adapter for each tool, it's time to test them out and see how they like their new Milwaukee batteries. They held up well to the test, so now I can use these tools confidently. I'm really happy to see the way these adapters came out. There's no problem using a lithium-ion battery with them. The tools look and work great, and I can now add a sawzall, planer, and hammer drill to my collection. It also adds an excuse to buy more batteries, and who doesn't want more batteries? The next project I wanted to tackle is the organization of my hand tools. I wanted a way to make these screwdrivers a bit more accessible and organized, so I designed and printed the screwdriver holder. This part is bigger than the build plate, so I had to get creative on how to put it together. With these Milwaukee toolboxes, you can pop off the inner lining so you can easily mount things to it. I have to use the screwdriver organizer more so I can determine which way I like to line up these screwdrivers. A feature I like about this is that the screwdrivers can't come out of their holders when the lid is closed. Now I have a functional and effective way to keep my screwdrivers organized. With the help of my 3D printer, I was able to take an unorganized and dysfunctional set of tools and turn it into a well laid out and functional toolkit with some special features baked in. Additionally, I restored some old tools along the way and gave them a second breath of life. I hope you guys all enjoyed, and let me know in the comments if there's something else I should add to my tool collection.